Okay, this is the fourth video for this smoke detector problem that I'm using as an example of doing a hypothesis test for proportion. Okay, so let's just recall what has happened here. The national average of the percent of smoke detectors in homes is 90%. And the city wants to know, did this campaign and all this money they spent on promoting the use of smoke detectors in homes, did that raise the proportion of smoke detectors in their city to be above 90%? So when we sampled the city, out of 400 samples, 94% actually had smoke detectors. So that is higher than the national average. So we used the conditions, we checked the conditions, and they're sufficient to use a normal model. So what we did was we created a normal model of what we would expect the sample statistic to be, 0.94. It should be somewhere within 3 or at least 2 standard deviations from the mean. Okay, so we did all these computations, and what we found that the sample statistic is actually 2.67 standard deviations, or 2.7 standard deviations away from the mean. So when we calculated the probability of that happening, it looks like it would happen less than 1% of the time. Okay, so the way we would do this is we would say something like this. The p-value, and I guess I forgot to mention that up here. The p-value is the probability of getting this sample statistic given the model is true. So the p-value is very small. It's equal to 0.4%. Okay? So, therefore, we reject the null hypotheses. All right, so a couple things here. Just make it very clear that you're going to reject the null. Okay, in this case, you don't have to restate the null. Don't do that. That's just say your evidence. Okay, so this is your evidence claim. My evidence is the p-value is very small. So my action is that I'm going to reject the null hypotheses. Okay, now again, the reason we're doing that is because the model says the p-value should occur in here, and the model says that it should hardly ever occur where we found it. But we did. We did find it there. Okay, so that's a contradiction. All right, the model is wrong. Well, if the model's wrong, then the null hypothesis is wrong. So since the null hypothesis is wrong, the thing that's right is the alternative. So that's what you add to your conclusion. Instead of rewriting the null, just say that the, what do we want to say? We restate the alternative. The public safety campaign has had a positive effect on the proportion of homes that have smoke detectors. In the city. Okay? That's how we would, those are the steps. Again, state the evidence. The evidence is the p-value is very small. State your action. You're going to reject the null hypotheses. You could say, if you wanted, we accept the alternative that the public safety campaign has had a positive effect on the proportion of homes that have smoke detectors in the city. Okay? So that's that. Now, if, let's just say that the p-value is high. So if p-value was, let's say it's 25%. So now we're not surprised. That would mean that the p-value is somewhere in here, very close to where we would expect it. Okay, so there we would say the p-value is high. There is insufficient evidence to reject the null hypotheses. That, and once again, we just go up and grab this language. Where is it? That the city is no different than anywhere else. That the city is no different than anywhere else. Okay, you need to be careful though if you do this, if you fail to reject. Okay, that's another way of saying it. The p-value is high, so we fail to reject. Okay, but don't say you proved the null hypotheses. That would be a big mistake. Don't say that. Again, it goes back to the jury trial analogy. Okay, we never proved O.J. innocent. There was just insufficient evidence to prove O.J. Simpson was guilty. All right, so that's an introduction. Hopefully this helps, but it really takes practice and just doing a bunch of them. So good luck.